They called it a weed. They classified it as invasive. They removed it from seed catalogs, banned it from farmland, and erased it from agricultural textbooks. But before that happened, this plant kept entire populations alive when wheat failed, when rice rotted, and when potato fields turned black. It required no irrigation. It thrived in soil that killed other crops. It stored underground for years without refrigeration, and when famine came, the civilizations that remembered it survived. The ones that forgot it collapsed. This is not about a forgotten vegetable. This is about a survival technology that was reclassified as a threat the moment industrial agriculture decided what you were allowed to grow. The plant is Jerusalem artichoke, Helianthus tuberosus. In modern agriculture, it appears on noxious weed lists. It is described as invasive, uncontrollable, and unsuitable for mechanized farming. But that classification is recent. For thousands of years, it was cultivated, stored, and traded as a staple crop. It was not a supplement. It was not a novelty, it was infrastructure. The archaeological record does not lie. Tubers have been found in storage pits across North America, preserved in conditions that would have destroyed grain. They were buried in quantities that indicate systematic agriculture, not casual foraging. These were not emergency rations, they were planned food systems. The plant produces tubers that multiply underground, creating a renewable harvest that does not require replanting. One tuber becomes 10, 10 become 100. The system regenerates itself. That is not a weed behavior. That is a designed survival mechanism. In pre-Columbian North America, indigenous agricultural systems centered around crops that required minimal labor and maximum resilience. Jerusalem artichoke was one of them. It was planted along riverbanks, in forest edges, and in areas where corn and beans would fail. It did not require tilling. It did not require fertilization. It required placement. Once established, it produced food annually without human intervention. The tubers were harvested in late fall and stored in underground pits, where they remained viable through winter. This was not primitive farming. This was a cold storage technology that functioned without electricity, without controlled atmosphere, and without chemical preservatives. The tubers contained inulin, a carbohydrate that does not convert to sugar until cooked. This made them stable in storage and slow to spoil. They could be buried in sand, kept in root cellars, or left in the ground and harvested as needed. The plant itself acted as the storage facility. You did not need a warehouse. You needed knowledge of where you planted it. When European colonizers arrived, they documented this system. French explorers in the early 1600s recorded vast fields of Jerusalem artichoke cultivated by the Algonquin and Huron peoples. Samuel de Champlain described them as tasting similar to artichokes, which led to the name. The Jerusalem part is a corruption of the Italian word girasole, meaning sunflower, because the plant is part of the sunflower family. The name is a mistranslation, but the function was clear. These tubers were a primary food source. They were not supplementary. They were foundational. By the mid-1600s, Jerusalem artichoke had been introduced to Europe. It spread rapidly across France, England, and Germany. It was not introduced as a curiosity. It was introduced as famine insurance. European agriculture at the time was grain-dependent, and grain crops failed regularly due to weather, disease, and war. Jerusalem artichoke offered an alternative. It grew in marginal soil. It required no maintenance. It produced food when nothing else would. The Great Famine of 1315 to 1317 killed millions across Europe. It was caused by relentless rain that destroyed wheat and rye harvests for 3 consecutive years. Grain stores rotted. Bread prices skyrocketed. Populations that depended entirely on cereal crops faced starvation. But there is a pattern in the survival records. Communities that had diversified their food systems, that had maintained root crops and tuber-based agriculture, had lower mortality rates. Jerusalem artichoke was not yet widespread in Europe during this famine, but other tuber crops like turnips and parsnips played a similar role. The lesson was clear: monoculture grain dependence was a structural vulnerability. Tuber crops were a hedge against collapse. By the time Jerusalem artichoke became common in Europe in the 1600s, it was planted specifically for this reason. It was famine food, but not in the sense of desperation. It was famine prevention. The plant's logistics were unmatched. A single acre of Jerusalem artichoke could produce 8 to 10 tons of tubers. Compare that to wheat, which in pre-industrial Europe yielded roughly 1 ton per acre in good years. The caloric output per acre was higher. The labor input was lower. The water requirement was minimal. The plant is a perennial, meaning it does not need to be replanted annually. It establishes a root system that persists for decades. This is not a crop you rotate. This is a crop you install. Once planted, it becomes a permanent food source. That permanence is exactly what made it incompatible with industrial agriculture. Mechanized farming requires annual planting, predictable harvest windows, and crops that can be processed at scale. Jerusalem artichoke does not fit that model. The tubers grow irregularly. They are difficult to harvest with machinery. They do not store well in commercial supply chains because they dehydrate quickly once removed from soil. These are not flaws. These are features of a decentralized food system. The plant was designed for household and community-level food security, not for export and commodification. During the Irish potato famine of 1845 to 1852, over 1 million people died. Another million emigrated. The famine was caused by a potato blight that destroyed the primary food source for the Irish population. Potatoes had become a monoculture crop, and when the blight hit, there was no backup. But here is what the historical record shows. Jerusalem artichoke was known in Ireland at the time. It had been introduced centuries earlier. It was grown in some areas, particularly in gardens and small holdings, but it was not adopted at scale. Why? Because British colonial agricultural policy prioritized cash crops and grain exports. Irish land was used to grow wheat and oats for export to England, while the Irish population subsisted on potatoes. Jerusalem artichoke, which could have provided an alternative food source, was not promoted. It was not subsidized. It was not integrated into the agricultural system. The famine was not a failure of nature. It was a failure of policy. The crops that could have prevented mass starvation were available. They were simply not prioritized. The numbers are brutal. Jerusalem artichoke requires 200 liters of water to produce 1 kilogram of food. Wheat requires 1 to 800 liters. Rice requires 2,500 liters. The water efficiency alone makes it a superior crop in drought-prone regions. It grows in soil with low nitrogen content, meaning it does not require synthetic fertilizers. It produces 0 methane emissions, unlike rice paddies. It does not require pesticides because it grows aggressively enough to outcompete most weeds. The carbon footprint of growing Jerusalem artichoke is negligible compared to industrial grain crops, yet it is classified as invasive. It is removed from farmland. It is actively discouraged in modern agriculture. The reasoning given is that it spreads uncontrollably, but that is only true if you define control as the ability to eradicate it on demand. If you define control as the ability to produce food reliably without external inputs, then Jerusalem artichoke is one of the most controllable crops ever domesticated. Modern research has confirmed what ancient agricultural systems already knew. Studies on Jerusalem artichoke show that it contains high levels of inulin, a prebiotic fiber that supports gut health. It has a low glycemic index, making it suitable for diabetic diets. It contains potassium, iron, and thiamine in concentrations comparable to potatoes. Nutritionally, it is not inferior to modern staple crops. It is equivalent or superior, but it has been removed from the food supply. In the United States, Jerusalem artichoke is listed as a noxious weed in several states. In Canada, it is classified as invasive. In Europe, it is grown in small quantities for specialty markets, but it is not part of mainstream agriculture. The plant that once fed millions is now treated as a contaminant. The reclassification was not based on toxicity. It was not based on nutritional inadequacy. It was based on incompatibility with industrial farming systems. The system that erased Jerusalem artichoke from agriculture is not a conspiracy. It is a structure. After the mechanization of farming in the late 1800s, agricultural policy shifted toward crops that could be planted, harvested, and processed with machinery. Wheat, corn, and soybeans fit that model. They grow uniformly. They mature on predictable schedules. They can be stored in silos and transported in bulk. Governments subsidize these crops because they could be exported. Seed companies standardize these crops because they could be patented. Agricultural universities research these crops because they received funding from industries that profited from them. Jerusalem artichoke did not fit. It could not be mechanized easily. It could not be stored in grain elevators. It could not be turned into a commodity. So it was reclassified. It went from staple crop to invasive species. The language changed. The policy changed. The food system changed. And the knowledge of how to grow it, store it, and use it began to disappear. This is not an isolated case. Amaranth was a staple grain of the Aztec Empire. It was banned by Spanish colonizers because it was used in religious rituals. The ban was enforced so thoroughly that amaranth nearly went extinct. It is now classified as a pseudo-cereal and grown in niche markets. Breadfruit was cultivated across the Pacific for thousands of years. It produces more food per acre than almost any other crop. It was introduced to the Caribbean as a slave food, and after emancipation, it was abandoned because it was associated with subjugation. It is now rare in global agriculture. Sorghum was a primary grain in Africa for millennia. It is drought-resistant and requires no irrigation. It was replaced by maize and wheat during colonial agricultural programs. It is now grown primarily for animal feed. The pattern repeats. Crops that require minimal input, that grow in difficult conditions, that provide food security without dependence on external supply chains, are systematically marginalized. They are not erased by accident. They are erased by design. The future is not speculative. It is observable. Climate models predict increased drought, more frequent crop failures, and the collapse of irrigation-dependent agriculture in multiple regions. Wheat yields are already declining in areas where temperatures have risen beyond optimal growing conditions. Rice production is threatened by saltwater intrusion in coastal deltas. Potato crops are increasingly vulnerable to heat stress. The crops that feed the majority of the global population are becoming less reliable. And the crops that were designed to thrive in unstable conditions, the crops that survived famines and droughts for thousands of years, are classified as weeds. When the next major food system disruption occurs, whether from climate collapse, supply chain breakdown, or geopolitical conflict, the crops that will matter are the ones that grow without permission. Jerusalem artichoke is one of them. It does not require a functioning seed supply chain. It does not require fertilizer shipments. It does not require irrigation infrastructure. It requires soil and time. That is not primitive, that is resilient. If this vault revealed something they tried to erase, subscribe to preserve what history tried to bury. Knowledge only survives when it is remembered. The next vault opens soon.